नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर आईटी जेई एंड नीट. This is our problem series for JEE Advanced. We are going to discuss the theory through problems. Hope this will be useful for all of you. I will request you to like and subscribe our channel. So in face-centered cubic metallic crystal, most of the question is asked from here and it is important for JEE as Advanced. So the first point is atoms are present at the corners and face centers. There are 6 face center. So at 14 sites atoms are there. So the number of atoms per unit cell is 8 into 1 by 8 plus 6 into half. Because the contribution of atoms present at face center is half, the contribution of atoms present at corner is 1 by 8. So there are 4 atoms per unit cell. And always valid condition here that nearest metal atoms will touch each other. So this distance is face diagonal half, that is a by root 2. A by root 2 is equal to 2r. But if I take the whole face diagonal, so this is r, this is 2r and r. So we can write root 2a is equal to 4r. So this is very important. From this, we don't have to mug up in any crystal. We have to find out nearest distance. Nearest distance is equal to 2r. So density is equal to mass of unit cell upon volume of unit cell. There are 4 atoms. So mass is 4 into atomic mass divided by Avogadro number upon volume of unit cell. Edge length is equal to, if we simplify, edge length is 2 root 2r. So on simplification, we'll get the density. Be careful about the unit of density. When it is kg, don't forget to divide by 1000. Packing fraction, again, we know that volume of atoms upon volume of unit cell. There are 4 atoms, 4 into 4 by 3 pi r cube upon volume of unit cell. So on simplification, packing fraction is 0.74, percentage is 74%. So it is highest packed in metallic crystal. 74% of the space is occupied, 26% is vacant, void fraction is 0.26. Now in this FCC metallic crystal, since as FCC metallic crystal is also known as ABCA type of crystal. So what is the logic behind that? If I want to make the closest pack of 3D, that closest pack of 3D should be formed when we repeat closest pack of 2D. So the closest pack of 2D is hexagonal closed packing. So there are these type of layers, and if this layer is A layer, then we are going to place B layer over it, and then after that C layer is present over it, and then A layer is present over it. So ABCA type of crystal. So when we are packing this crystal, if we want to see in a unit cell how it is going to relate it, so I can say that there are 4 layers, right? So this is face diagonal plane. Face diagonal plane, this is in blue color. We can see that it is passing through the top face diagonal, then right hand side face diagonal, and then front face diagonal. There are 3 atoms over here. There are 1 and 2 atoms over here, and there is 1 atom over here. So if you see here, this is these 3 atoms are touching at each other. This atom is between these 2 atoms, and this atom is between these 2 atoms, and this is the bottommost atom. So this is the structure. This structure is coming from this 2-dimensional hexagonal packing. So if I want to calculate what is the packing fraction of 2-dimensional hexagonal packing, I can take a triangle, because this regular hexagon can be found by repeating this equilateral triangle 6 times. So packing fraction of 2D is equal to, because there are these 3 spheres and this triangle means this sphere is 1/6, angle is 60 degrees, so 1/6. There are 3 such spheres, so 3 into pi r square divided by 6 upon. For an equilateral triangle, we can write area is equal to under root 3 by 4. Edge length is equal to 2r whole square. If you simplify, this is pi by 2 root 3, which on simplification will give 0.907. Better to remember the data, 0.907, 90.7% of the space is occupied in HCP 2-dimensional crystal. So when we are discussing, this A layer is HCP 2-dimensional. This B layer is HCP 2-dimensional. This C layer is HCP 2-dimensional. This A again will be the same. So these are 2-dimensional closest pack layers. On repeating it again and again, we can form the whole crystal. So here why its name is ABCA, because here from here there is a HCP layer passing, then we can say that this face diagonal plane, this bottom face, back face, and left hand side face, this face diagonal plane, then this top face, front face, and back face, only two atoms will be left, this corner and this corner. So from here also one layer is there, like this layer, and here also this layer is there. So that's why it is known as ABCA, ABCA. So this is body diagonal from A to A. So the distance is under root 3A. So this under root 3A, because there are four layers, so between them the distance is x, x, and x. So we can say that 3 times of x is equal to under root 3A. The question is find the nearest distance between AB plane in ABCA, ABCA type of crystal. So simple face centered cubic crystal mein we have to find out the perpendicular distance between the parallel planes. So that we can find out by this method. Under root 3A is equal to 3x. So x is equal to a by root 3. And in FCC, a is equal to 2 root 2r. So if we simplify, this value is equal to under root 8 by 3 times of radius of atom. So this is also very important relation, perpendicular distance between two parallel planes in FCC metallic crystal. Now in this FCC metallic crystal, there are three type of face. This question is asked in JEE Advanced, so I'm discussing because this is very common now. So the first plane is face plane. There are 6 faces in the cube. If you see here, there are atoms at the corners and face center. So this is face plane. And this atom at the center is touching all the atoms at the corner. This atom is touching all the atoms at the corner, but these atoms are not touching each other. So if I calculate that, what is the packing fraction? So packing fraction, if I calculate, this angle is 90 degree, 90 degree, 90 degree. So if I combine here, so this is 1/4 of this atom and this is complete atom. So 1/4 into 4 will be 1. 1 plus 1 will be 2. So area occupied is 2 times of area of the circle upon area of this face plane, that is square. So edge length whole is square. So now if we simplify that, what is the packing fraction of face plane? Packing fraction of face plane is equal to pi by 4. So this pi by 4 is 0.785. So this is square packing of 2 dimension, square packing. And we can see that if we see by some angle, like this is one layer, this is A layer, this is a B layer, this is same as A layer, because at this position and this position, at the same side, atoms are there. Again, if we move forward, here there will be an atom and here there will be atom. Same way we are saying that there is an atom here. So it is simple cubic. In case of simple cubic, when we are finding that a bottom plane of the cube, there are 4 atoms, and it is similar to that. If you see that this atom is touching this atom, similarly this is touching this. So if you combine them, it is a face plane of simple cubic, right? So the packing, from the packing we are saying that it is a square packing. So face plane of FCC metallic crystal has a square packing whose packing fraction is equal to 0.785. The second point is diagonal plane. When we are discussing about diagonal plane in this diagram, this is face diagonal top and this is face diagonal bottom. So if we draw this plane, it is like this. And these 3 atoms are touching each other. These are not touching each other. These 3 atoms are touching each other. So from here, if I calculate what is the packing fraction, that is same method, area occupied. So this half and this is 1 by 4. 1 by 4 into 4 is 1, and this half and half is, so 2 atoms are there. So 2 pi r square upon square area, that is under root 2a square, and a is equal to 2 root 2r. If you simplify, you will get this packing fraction. So this is diagonal plane of face centered cubic metallic crystal. Face plane, diagonal plane. Now the third plane is important. This is, okay, here we have discussed, but in this, if we want to see that what is the face diagonal plane, so with the help of top face, right hand side face, and this front face, this plane is known as, it is formed by 3 face diagonals. So that's why its name is face diagonal plane. And we have already discussed that for face diagonal plane, we have discussed that this is face diagonal plane. So it is hexagonal packing of 2 dimension, right? So packing fraction is equal to 0.907. So there are 3 planes asked in JEE Advanced in 1999, and these are very common question now. So you should know about this face centered cubic metallic crystal. Thank you.